Hello everyone. We are the students of final year Environmental Science and Technology from SROF SR Rotary Institute of Chemical Technology. Our project ID is 131727. The topic of today's presentation is removal and evaluation of inorganic substrate and ammonical nitrogen by novel combined process in treating alcohol or paint-based intermediate effluent. Our project is guided by Ms. Bhasa Mehta, Assistant Professor of Environmental Science and Technology Department, followed by an e-poster and video presentation.
The main purpose of our study is to choose a chemical process which can efficiently remove ammonical nitrogen from the effluent. So we can magnify the process which is being used by industries through a modified pendant process and its combination. Moreover, our proposed design can replace the resin tower. In recent years, with an increase in the stringent water quality regulations due to environmental concerns, the removal of nitrogen from wastewater has become an emerging worldwide concern because these compounds cause eutrophication in natural water. Moreover, it can damage human health and environment. Therefore, a post-treatment is required to remove ammonical nitrogen from effluent. According to current scenario, industries are using resin tower for removal of ammonical nitrogen from effluent, but it is expensive and have problem of backwashing. Hence, we need a novel process to deal with this problem.
Our main objectives are to remove ammonical nitrogen from the effluent and to replace resin tower by our process. And at last, to determine the exact methodology for this. So now we will see the methodology. As this is our experimental methodology, which includes three different alternative process. That is, in first experiment, we'll treat the effluent with Fenton process and then with the sodium hypochlorite and calcium hypochlorite. Likewise, in second experiment, again the effluent will be treated by Fenton process, but after that we'll alter the chemicals. As first, we'll use calcium hypochlorite and then we'll use sodium hypochlorite. And in last, that is third experiment, first we'll treat the effluent by these chemicals such as calcium hypochlorite and sodium hypochlorite. Then we will treat the Fenton process. Although while performing this experiment, we have to find the initial pH and also set up to pH 3. After that, we have to also find the optimum dosage of ferrous sulfate and hydrogen peroxide, through which we can reduce the maximum concentration of ammonical nitrogen. And lastly, to find the optimum reduction through this process. So this is our overall process which we will be performing.
Now, moving on to 2D design, we have two flow diagrams. One is the existing design and the other one is our proposed design. In the first flow diagram, effluent which comes from production plant gets treated with resin tower and then collected in the guard pond. But after some time, the resin tower gets saturated and it needs to be backwashed. And again, we have to treat backwashed water having high concentration of ammonical nitrogen. Now, in the second flow diagram, we are trying to replace the whole resin tower with our process, which is Fenton along with its combinations. Hence, in this process, there will be no generation of backwashed effluent, and moreover, our process will be cheap and economical. Now, let us see the slight comparison between existing process and our process. The existing process is having backwash problem. It is having large space requirement. Various mechanical equipments are required. Hence, high maintenance is required. While in our novel process, there is no backwash problem, no large space is required, no high maintenance is required, and it is way more cost effective than the existing system.
Now, let's see some advantages of our process. No large space required. no problem of backwashing and handling, cost effective, no maintenance required, leads to sustainable development and low consumption of non-renewable resources.
By this study, we have concluded that our experiment is one-time investment process. By this process, we are taking steps towards clean and green environment. As we are replacing resin tower, this process become economical and environment friendly. This also leads to sustainable development. Hence, such novel process is the need of hour. Thank you.